Hi guys, this is Miss Raina, your trusty physics teacher coming to you from C347 at MacArthur High School, here to talk to you today about Newton's 3 laws. The first law, I want you to look at your worksheet. At the very top, right under where it says flip video notes, we're going to look at the law of inertia first. So the law of inertia says that an object at rest stays at rest, an object in motion stays in motion unless acted upon by an unbalanced force. So what's an unbalanced force? Well, it's exactly what it sounds like. If it's balanced out, then it's canceled out, and so it's not going to accelerate anything. Another way to put it is that an object in motion will stay in motion, and when we say in motion, we mean it's got the same speed and it's going in the same direction, unless it's acted upon by an unbalanced force. What happens if the speed changes and or the direction changes? We have acceleration. In order to get acceleration, we need to put a force on it. So what's inertia? If something has a big mass, then it's going to have a big resistance to change in motion, and that's what inertia is. Here the mule has a big mass, and so he's really resisting this guy's efforts to change his motion. Here's another way of thinking of Newton's first law of motion. As crummy as I am a sport, the more that I will the putt-putt golf ball to go into the hole, the more everybody laughs at me because my will is not going to do it. I have to apply force to change its motion to make it go into the right direction. If I can't do that, it's not going to work. As far as you and Newton's first law, here's where you have to be really careful and why. Do not let this be you. Make sure you wear your seatbelt. Because of inertia, anything in the car, including you, is going to resist change in motion. So if your car runs into an obstacle at 80 miles per hour, that's supposed to say miles per hour, you will not stop. Your mass will continue keeping up with its motion. It's going to resist change in motion. It means that your body's going to keep moving and your limbs are going to get strained a little bit. All right, so let's move on to the second law. The second law, I want you to write it down in this form first, in kind of like a word equation. What it means is acceleration only happens when there's a force acting on a mass. You can also write in this equation form. So put it in the word equation, write it down in words, and write it down in the equation form on your notes page. All right, here's another way of thinking of Newton's second law of motion. This is just a reminder of what acceleration means. How are you going to calculate acceleration? And we'll look at that next. If you have, you're applying force to a certain mass, then you'll get some acceleration. Now, what happens if you have more force? Look for the little arrows on your paper. If you have more force on the same amount of mass, well, hey, you get more acceleration. If you apply the same force to more mass, it's going to be difficult. It's going to be more difficult to get it to accelerate, so you'll have less acceleration. If you like it visually, there it is there, or if you want to see it visually in the form of an equation, then you should write those things down. So keep in mind, pause whenever you need to. Here's a little reminder of what acceleration means. It's talking about change in velocity over time, and this could be in the form of changing speed or in the form of changing direction. So here are a couple of reminders. What exactly do we mean by these final units? Well, if you take meters per second, you end up with meters per second squared. All right, so here's another way of thinking of Newton's second law. And I want you to look at the units involved in Newton's second law. So we'll use kilograms for mass. We'll use meters per second squared for acceleration. And if you multiply those two, a kilogram meter per second squared, we're going to call that a Newton. So I want you to measure force in newtons. And when you do your calculations and you end up with this combination of units, simplify it and write it as this form, Newton. All right. Some of you have seen this video on YouTube. If you have, great. If not, it's hilarious. Have a look at it when you're on your own time. But bottom line, Newton's law says for every action there's an equal and opposite reaction. So if you put this in terms of being on a pretty low friction surface, you can throw a mass out in that direction, a ball for example, and you will be propelled in this direction. but it's going to be an equal and opposite reaction. So that mass is small. If you give it a big velocity, then you have a big mass compared to the mass of the ball. You'll get propelled with a small velocity in the opposite direction. Here's another example. A bird flying gracefully through the air. It pushes down on the air pushes back up on the bird. You get some lift. Final example, you hit the ball with the baseball. The baseball forces the ball one way. This is hard to say. The bat forces the ball one way. The ball, and you feel this if you're like me and you're sports impaired and you can't seem to get this right, the ball will force the bat in the opposite direction. It'll make it kind of wobble, and it kind of hurts your hand if you're not hitting it in exactly the right spot. Okay, so this is the last slide. Everybody feel free to pause and take your time writing all these facts down. Different types of forces. I will say force of weight. I will not say force of gravity if we're doing mass times gravity to figure out what your force is on the floor, for example. The force of the floor supporting you, holding you up, we call that normal force. It's always going to act in an equal and opposite direction to your force of weight. It's always going to be perpendicular to the floor, for example, or the chair, whatever it is that's supporting weight. Tension is always a pull, usually on a chain or a string. Friction is a force that opposes motion, usually from rubbing, like on brakes or like on the tires of your car. And an applied force is basically anything else, some kind of a push. If it's not one of the other four categories, we call it an applied force. So thank you very much for hanging out with me throughout the Newton's Laws flip notes, and we'll see you tomorrow in class. Be sure to write down any questions you have so we can discuss them.